Hello! Welcome to today's lesson on sparking and lightning. Today, we will understand the process of sparking as an example of static electricity in everyday life. Then we will understand lightning as an example of sparking. Finally, we will explore the energy transfers that occur during a lightning strike. So far, you are familiar with the basics of static electricity, which involves the buildup of electric charge. Let us examine another common phenomenon known as sparking, which can be explained by static electricity. Have you ever experienced a sudden shock or seen a small spark when touching a metal object? When you shuffle your feet on a carpet, friction between your shoes and the carpet causes electrons to be transferred from the carpet to you, giving your body a negative charge. Now, let's say you reach out to touch a metal doorknob. Since your body is charged, there's now a large potential difference between you and the doorknob. The air between your hand and the doorknob normally acts as an insulator, preventing the flow of electricity. However, when the potential difference becomes large enough, the air can no longer prevent the flow of electrons. At this point, electrons will suddenly move from your body to the doorknob and jump across the gap to equalize the charges, creating a spark. This spark is actually a small electric current flowing through the air, which heats up the air and produces light and heat. The spark you see and feel is this rapid discharge of electricity, which can sometimes be strong enough to cause a shock or even ignite flammable substances. Lightning is an extreme example of sparking in nature. During a thunderstorm, clouds are filled with ice particles, water droplets, and dust. These particles are constantly moving and colliding with each other due to air current within the cloud. When these particles collide, electrons are transferred from some particles to others. As a result, different parts of the cloud develop different electrical charges. Specifically, the top of the cloud generally becomes positively charged, while the bottom becomes negatively charged. Eventually, the charge difference between the cloud and the ground, or between different parts of the cloud, becomes so great that the air, which normally acts as an insulator, can no longer resist the flow of electricity. When this happens, a massive discharge of electricity occurs, which we see as a lightning strike. This lightning bolt is essentially a giant spark, where electrons rapidly move through the air from the negatively charged part of the cloud to the positively charged ground or another part of the cloud. The movement of these electrons through the air heats it up rapidly, causing the bright flash of lightning and the sound of thunder that follows. To fully understand this, let's examine it in terms of energy transfers, recalling our knowledge from the energy unit. As the thundercloud is charged, energy is stored as electrostatic energy. This energy is then transferred through electrical work as the electrons flow rapidly from the negatively charged bottom of the cloud towards the positively charged top of another cloud, or down to the ground. As the lightning bolt moves through the air, it meets resistance from the air particles, causing the surrounding air to heat up to extremely high temperatures. This is an example of energy transfer through heating. This heating significantly increases the thermal energy of the air. The heated air then radiates energy in two forms. It emits light, which we see as the lightning flash. The rapid expansion of the heated air also generates sound waves, which we hear as thunder. Lightning demonstrates a rapid transfer of electrostatic energy into various forms, including heat, light, and sound, releasing vast amounts of energy in a short duration. In today's lesson, we focus on the phenomenon of sparking, using lightning as a prime example within the topic of static charge. We learned that lightning is a massive discharge of static electricity that occurs when there is charge imbalance. This imbalance is due to the buildup of static charge, where electrons accumulate in one area, allowing a current of electrons to flow and creating the characteristic spark we recognize as lightning. By examining the energy transfers involved, we've gained a deeper understanding of how electrostatic energy can be converted into other forms of energy, such as heat, light, and sound. Whether it's the small shock you feel after walking on a carpet, or the awe-inspiring power of a lightning storm, these examples demonstrate the significant impact that static electricity can have in our world.